Another problem that message queues are good at solving is the slow consumer problem. Let's take a look at what causes a slow consumer. So here I have a typical data upload workflow. So here I'm going to have my data uploader that makes a HTTP request to some web server, and then that web server is going to save the data that's uploaded to the database. And then after that happens, the web server is going to respond to that request, but it doesn't really return any data. It's just an acknowledgement that that data has been saved. So let's take a look at where the slow consumer can cause problems. So assuming that this database can only save one record per second because it has to persist that data into some permanent storage like a hard drive or SSD. So that's going to be slower than if everything was done through memory or through the network. And this data uploader is very fast and it can upload 5 records per second to the web server. But since this database can only process one record at a time, that means that either the data uploader has to be throttled, so it can only pretty much send an average of 1 record per second, or the web server has to buffer. So basically it will take those 5 records and then take its time saving it one by one at 1 record per second. So if the web server is to buffer those messages, that means that it has to be reliable. So for example, if the web server crashes, then that means we have a potential for losing all those records. So this is a problem, especially if you also have multiple data uploaders that are performing at different rates. Therefore, this is why it's a problem, because you have fast publishers, which are these data uploaders, and then you have a slow consumer, which is the one that's saving it to the database. And then in this case, either you buffer in the web server, but this buffering has to be reliable, and normally that's not really the job of the web server. Otherwise, this web server has to throttle these data uploaders, so it's exposing the limitations of this speed for saving. That's 2 problems that neither one that you want to have, right? So let's take a look at how you can fix this slow consumer problem with message queues. Okay, so by introducing a message queue to this workflow, you actually make it more scalable. So here's what I mean. So this message queue will act like a buffer between the fast publisher and the slow consumer. And then it also takes away the responsibility of the web server from buffering. So here, this new workflow is going to be the data uploader is going to send the data to the web server. And this web server is going to create a new entity called the publisher. And this publisher will be responsible for transmitting the data that is from the data uploader to the message queue. And then once the data is in the message queue, this data saver is a new process that will take those messages from the message queue and then save it to the database. And after it saves it to the database successfully, you can then act those messages on the message queue so that the message queue can remove those messages. So this is a more scalable design, because if for whatever reason the data saver is not online, that this message queue can still hold those messages that are pending to be processed reliably. And also the limitations of this data saver will no longer be exposed to this data uploader, because this message queue will become a buffer between this fast publisher and a slow consumer.